All right, so today we're going to get into scattered plots. Again, this may be something that you have seen before or may not. But basically, what we're going to go over is different scattered plots and how they deal with correlations. So what is a correlation? Well, a correlation is the general type of relation shared between two variables. More specifically, our x variable, our independent variable, and our y variable, which is our dependent variable. There are three major types of classifications for correlations. We have a positive correlation, which often has a positive slope, a negative correlation, which often has a negative slope, and then something known as no correlation, which just represents that there's no clear pattern. And so this is what those correlations look like. A positive correlation, when I mean that it often represents a positive slope. Say we had a distinct linear line that runs through here. That slope would be going upwards, and so that would be a positive slope. When we have a negative slope, that slope would be going downwards, and so that's why we would have a negative slope, and that would be negative correlation. And then if we can't draw a distinct line like you see here, there's no real correlation between the x and the y, so we would have no correlation. Again, you may have seen this before. Okay. So how do we interpret correlation? So, for example, here we have something that represents the tree height and how that affects the annual salary. Okay? And as we can see, the data is positively correlated, right? That data is running at a positive slope, right? Well, this is telling us that the increase in tree height does not cause a higher annual salary. They're just correlated to each other. So it doesn't cause the increase in salary. It's just correlated to it. It does not tell us that a higher annual salary, it tells us that, a higher annual salary does not cause the tree heights to increase on the other hand, right? We can just see that there is a correlation, but we can't necessarily say that there's a cause. So whenever we see something like this, what we can't say there's a cause and effect relationship. All there is a correlation. Okay, so correlation does not imply a cause or effect relationship. So that's something to keep in mind. Okay, any questions about this? So correlation does not cause things to happen. It's just correlated to it. Okay. So we're going to look at a trend line. What is a trend line? A trend line is a linear function that models the linear pattern in a data set, kind of like what I drew in our other data sets. This trend line often represents our slope, and it helps us to find what the correlation is. So we might be asked to find the equation of a trend line. And the way that we do that is we draw a line that approximates the pattern. So like there you see that black line, that's drawing the line that approximates that pattern. It looks like it's kind of a positive correlation, right? Because it goes upward. And then in order to create an equation, what we want to do is choose 2 points on the line, compute the slope using those points, and then write an equation using point slope formula. So for example, say that I chose 2 points. 10 and 1800 and 15 and 2300, right? So those are my 2 points. Now what I want to do is compute the slope between those 2 points. I want to find the slope that represents those 2 points. So I'm going to use my slope formula. y2 minus y1, x2 minus x1. And what I'm doing here again is finding the equation of the trend line. Okay, now I substitute in my variables. And what I get is 500 over 5. 500 divided by 5 is 100. So my slope, my m, is 100. Okay? Well, I'm not given any direct information here about my y-intercept. And so because of that, I want to use my point slope formula to find the equation of this trend line, this black line, right? And so my point slope formula my point slope formula is the equation that looks like this. Y minus y1 equals m times x minus x. Right? Okay, and so now I can go ahead and plug in. My y is my constant, y1. I'm going to use 1800 equals my m, which was 100. X is my constant, x1 is 10. And now I can go ahead and rearrange this to find the equation of my trend line. So distribute this, 100x minus 1000. Chop this one down. Isolate my y, so let me add 1800 to both sides. And when doing so, I get y is equal to 100x plus 800. And so this represents my equation for my trend line. So how do I find the equation for my trend line? I choose 2 points on the line, find the slope, and then write the equation using the point slope form. Okay, any questions about how I find the equation of the trend line? Questions, concerns?
No, ma'am.
No? Okay. Okay. What we can also do is use trend lines to make predictions. So what we're going to see here is that we can use our trend line, and here we're given an exact equation for a trend line right here. Y equals 0.3x plus 110. So once we are able to find our equation for our trend line, which in this case it gives it to us, what we're able to do is actually make predictions. So we're able to predict how the trend line will act as it moves further down the graph, right? So if the graph were to extend out, we're able to predict what the relationship and how it will be affected. Okay, give me 1 second. One second. Okay, so the way that we are able to identify how the trend line will act as we move further down in our x values is that all we have to do is plug in these x's. So for example, let's look for the earning for sales for $80, sorry. Okay. Well, we see that it's right here. But what we see is that we're not given a clear y. Right here. But can we find a clear y? Yes, we can. And the way that we would do that is we would plug it into the equation for our trend line. So 0.03, 80 plus 110. What does that give me? 134. So when I have an earnings for sales of 80, I get 134. Okay. What about when I have an earnings for sales of $0? What will my earnings be when I have a sale of $0? Well, 0 is about right here. And as you can see, I'm not given any clear y, and so I can go ahead and plug that in. 1 second. And that will give me equals to 110. Okay. So what about this one? Earnings for sales of 400. Well, as you can see, 400 is not even on the graph. It would be somewhere all the way over here. And so how do we find the earnings for sales of $400? Well, very similarly, we would just plug it into our trend line. So that's why it's important to have an equation for the trend line so that we are able to make predictions that exist outside of our data set. So this would give me 230. Okay. And so what are we looking at here? Well, we're looking at interpolation, which is the estimations of points in between data sets, or in between the data you know. So basically, these two would be interpolation. Why? Because they exist in the data set, but they exist in between the points that we are given. Okay? We also have extrapolation, which is the estimation of points outside the data set. So that would be this one right here. And why is that extrapolation? Because it is asking us to identify earnings for sales of 400, which is beyond the data set that we are originally given. So by finding the equation of the trend line, we're able to make predictions using interpolation or extrapolation by plugging in different x values into our trend line equation. Okay? Any questions about what we're doing here? Questions? So first thing, identify that trend line, and then that trend line helps you find estimations of points in the data, in between data sets and outside data sets. Okay. And lastly, we're going to look at the correlation coefficient. The correlation coefficient, or R, is the value between -1 and 1 that measures the strength of the correlation between two variables. So let us remember that we looked at the different types of main correlations that we have, right? We often have positive correlation, negative correlation, or no correlation. And so what the correlation coefficient R tells us, it helps us determine whether we have a perfect positive correlation, a moderate positive correlation, no correlation, a moderate negative correlation, or perfect negative correlation. So basically, the R we're given helps us determine the type of correlation that we have in a data set. And so what we can actually do is we can use a graphing calculator to create a scattered plot, find the trend line, and calculate a correlation coefficient. Okay? So let me show you what this actually looks like. Okay, give me 1 second. All right. Hold on. Let me zoom in here. This down, zoom in here. Okay. And then share my other screen. Okay. Yeah, share window. Okay. Let me show you what this looks like right now. Okay, so I'm going to show you what I mean by you can use a graphing calculator to find the correlation coefficient. So say we have this graph that we just looked at. And say I want to find what the correlation, what type of correlation I have here. And so the way that I would do that is I would use a correlation calculator. I'm going to use this one right here. Let me see. How can I do this? All right. Let's see here. Okay. So basically, I'm going to plot different points for that line we just saw. And I'm going to plot these points, and you may be asking, how am I getting my different y values? Well, I'm getting my y values by plugging in these different x's that I'm putting here into the equation of the trend line I had. So the y equals 0.3x plus 110. So I put these different x values into that and got a specific y. And so now I'm going to use my calculator to find what my correlation coefficient is, or I'll even be given my linear regression equation, but I was already given that, so I don't need to identify that. So okay, and so what you see here is I am given my correlation coefficient. And because I have 1, what I will find is that I have a perfect positive correlation, right? And then you can see here, I got the same linear regression equation or trend line equation that I had before, right? So this calculator will give me that equation, and it will also give me the correlation coefficient. But what does this correlation coefficient tell me? Well, as you can see here, when I have a positive 1, like I do here, I have a perfect positive correlation. So that tells me that my x and y values have a perfect positive correlation. Okay? Any questions about this? Questions? So you can use this calculator to go ahead and help you create a scattered plot. It can help you find the trend line and the trend line equation if you have all the data sets, meaning the different coordinates, and it can help you calculate the correlation coefficient. Okay. All right. So what did we learn today? Well, we looked at scatter plots, and scatter plots can be used to identify relationships between data, right? It helps us identify the relationship and what the correlation is between our different variables, the x variable, the independent variable, and the y variable, the dependent variable. The linear regression is the process of finding the equation of the line of best fit, right? And we're going to do a brief reminder on how to find that equation. And then the correlation coefficient R helps us measure how linear the scattered plot is, or how the correlation is. What is the type of correlation that we have? Okay. So a reminder, how do we find the equation for the line of best fit or the trend line? Well, we draw a line that approximates the pattern, choose 2 points on that line, and then compute the slope using those points, and then write an equation using point-slope formula, which we looked at already. Okay? And then how do we make predictions using the line of best fit? Well, once we have that equation, what we can do is we can substitute values into the equation, different x's. And by doing so, we're able to make predictions that exist beyond the data set or in between the data set, right? So we're able to get more accurate information about how our x's relate to our y's. And then if we want to find the regression equation or the correlation coefficient, we can use a calculator with those features to do so. Okay. Any questions about what we went over today?
No, ma'am.
Okay. And like always, we'll go over some practice problems tomorrow, and you'll be able to see how we're going to use this information to actually answer problems. But if there's no other questions right now,